Hi, everyone. I'm Sarah Larson from the Multiplicity Lab Group at Northwestern University. Today, we're going to explore one type of look, think, talk activity where the question you ask of students is, which is more? As a quick reminder, in look, think, talk activities, you first show students an intriguing mathematical image and give them time to look. This can be done on a shared screen, or you can print copies for students. Then you pose a central mathematical question and give students time to think. If students have printed copies, you can invite them to annotate as they think. Students can also use manipulatives as an entry point into the task. Finally, ask students to talk about the question with one another and as a whole group. The goal of these discussions is to elicit and encourage multiple ideas, strategies, ways of seeing and thinking, and connections, all while making room for multiple voices. The question, which is more, is inherently about comparison and understanding what makes two quantities equal or not. But depending on the image, it can involve several other big ideas as well. Students might need to grapple with units as they compare. For instance, if comparing baby penguins and adult penguins, they will need to recognize that the babies are smaller than the adults, so they can't use the space each takes up as a proxy for counting. One key to the question, which is more, is that we are not asking precisely how many, but rather students need strategies for estimating which group or space is larger. This opens up a whole range of potential strategies for comparison that don't involve counting at all. Students might use the structure of the image or the units being compared to help them draw conclusions about which is more, a key mathematical practice. And that structure could support students in accessing other big ideas, like thinking in equal groups or relating part and whole. Let's look at a few examples and consider where they could take you. Which is more? Consider the many ways that a student could answer this question and the role that units play in their different answers. If the unit is coins, then the left side clearly has more than the right. Little evidence other than appearance would be needed to justify that claim. But if the unit were specific coins, then the left side has more pennies, nickels, and dimes, and the right has more quarters. However, if the unit were cents, the value of each side is money, then the balance is much closer. The left side is worth 51 cents, while the right is worth 50 cents. How students figure that out is something worthy of discussion. And it's also worth pointing out that the values are so close while looking very lopsided. Our eyes can deceive us with coins. This could raise questions like, how could we make the two sides equal? Or what other sets of coins could you make that look very different but have values that are close to the same? Let's look at another example. In the real world, which is more questions are all around us. Look at this image of the Golden Gate Bridge from above. Are there more cars on the left or the right? In this case, students might count the cars one by one or subitize the cars into groups. Here, depending on how you count, you might find that there are an equal number of cars on the left and right. Students might also debate some parts of this image, like the car partially under the middle, or whether the objects in the green box are cars. This could lead to some qualified answers like, if the car halfway under the barrier counts as on the right side, then the cars are equal. If the objects in the green box are cars, then there are more on the right. Considering conditions is a part of mathematical thinking too. Sometimes counting is not possible. Look at this image. Are there more buffalo in the water or out of the water? Counting is not efficient and maybe not even possible here. Instead, students will need to draw on other ways to estimate, such as considering the area the two groups take up and whether their density is similar or not. Because this is inherently an estimation task, students have to justify their claims with evidence and strategies that others can follow and find convincing. Which is more is a meaningful question for every grade from kindergarten up. We have dozens of which is more activities at Multiplicity Lab. To find these, begin looking at the Look, Think, Talk tab. You can use our filter to select the question, which is more. And if you'd like to narrow your search, you can select a grade level or material, like coins, playing cards, or real-world images to match your goals. Try a which is more activity with your students tomorrow.